Welcome, Hornets, and thank you for joining me today. Today we're going to be finishing up assignment number 11, which will be the 31 through 41 odds only from page 442. So we're going to go ahead and we're going to start with number 31. Let me just give everybody who is online and watching this the opportunity to see the page and potentially get a screenshot for those of you who are interested. Alrighty, so we're going to be doing number 31, which is the x cubed minus 3x squared plus 3x, and g of x equaling x squared. You'll notice I feel it's just as important to multiply that x all the way through. Now, they are asking us to find the intersections. They are asking us to graph the graph and then try to do the integral. So I've already taken the opportunity to go through and find out what this graph looks like. And it is a cubic. It's going up like this, turns and then goes up. And then we have a quadratic that cuts through. There's our, let me make sure I do it nice and flat there, because this is a intersection right there. It goes up and then intersects up top here. Now, the intersections that I found were the 0, 0, 1, 1, and 3, 9. To find those intersections, you set the g of x and the f of x equal, and then simply solve. This is where you're using your Algebra 2 skills to find your solutions. Now, you'll notice I have my representative rectangle right here where the cubic is on top. So this top part is going to be the x cubed, let me write it as x comma x cubed minus 3x squared plus 3x. And this bottom piece is going to be the x comma x squared. And then we have our representative rectangle right in here. And now you'll notice that we have x comma x squared. And down below is now the x comma x cubed minus 3x squared plus 3x. Now, this is where we do this. We have the orientation change, so we do have to watch out. So we're going to be looking at this as the integration from 0 to 1. And if you take the opportunity to simplify x cubed minus 3x squared plus 3x minus x squared, you're going to end up having 0 to 1, and you have x cubed minus 4x squared plus 3x dx. Working with the second piece, we have 1 to 3, and now we have our x squared on top minus x cubed minus 3x squared plus 3x dx. Excuse me. This gives me the integration from 1 to 3. And we now get the opposite, negative x cubed plus 4x squared minus 3x dx. And now we're going to integrate. So we are looking at 1/4 x to the 4th minus 4/3 x cubed plus 3/2 x squared from 0 to 1 plus, this is now the opposite, so I now have a negative 1/4 x to the 4th plus 4/3 x cubed minus 3/2 x squared, and this is from 1 to 3. We're now going to plug in our values, and as we do so, we are going to find out that this entire thing is going to give me 1/4 minus 4/3 plus 3/2 minus 0, and that simplifies to give me 5/12. This piece right here is going to end up being the negative 81/4. I then have plus 36 minus 27/2. minus negative 1/4 plus 4/3 minus 3/2. And that's going to simplify down to 37/12. So I have this 5/12, and I'm adding to it 37/12. And I end up having a total, 32/12. Let's make sure I get that right. 32/12. And that's after getting the common denominator, because we end up having this equaling 8/3. Gives me 32/12 for a total of 37/12 is our answer. And that's number 31. Number 31. This brings us to number 33. Number 33 has an f of x. That is x to the 4th minus 4x squared, and a g of x. That is x squared minus 4. So we're going to go ahead and we're going to graph this. Now be aware it is symmetric to the x-axis. So we are looking at something that goes up, like so. The point of intersection that I found here was -2, 0, and 2. And then I have a quadratic. Cuts down like this. And I found 2 points of intersection for this. They were at -1 and 1. And I can clearly see that they are symmetric. Now I'm going to use the symmetric property of integration in order to do this. That says that if I have an even function that is symmetric along the x-axis, I can say that I have two areas that are the same from 0 to 1 for the upper quart, x to the 4th minus 4x squared minus the quadratic x squared minus 4 dx, and add to it 2 of the integration from 1 to 2, where I now have the quadratic on top, x squared minus 4, minus the quartic, x to the 4th minus 4x squared dx. This allows me to do less work so that I have two very clean problems and can work with them quickly. Now I'm going to rewrite it so that it's simplified. And I end up with 0 to 1. And I have x to the 4th minus 5x squared. And I'm looking at a positive 4 dx plus 2 integrations from 1 to 2. And now I'm going to simplify this as negative x to the 4th plus 5x squared minus 4 dx. Notice that they're opposite. That's something to keep in mind. We're now going to integrate. So I'm looking at 1/5 x to the 5th minus 5/3 x to the 3rd plus 4x divided by 1 from 0 to 1 plus 2 times. Now we have the opposite, negative 1/5 x to the 5th minus 5/3, so double negative, plus 5/3 x to the 3rd. And then I have minus 4x, and we're going from 1 to 2. Now as we put this in, we're going to get 2 of our 1/5 minus 5/3 plus 4. That's from the 1. The 0 causes it to go away. And we're doing plus 2 times. And now we have two different pieces. So our first is negative 32/5. We have plus 40/3. And we're subtracting 8 minus. Now we're putting in the 1 for minus 1/5 plus 5/3 minus 4. And we're going to want to add this together, multiply both by 2, and we end up getting 8 as our total. I'm going to leave that for you. It's just going through and finding our values. That's number 33. Let's go ahead and move on to number 35 now. Let's just remind ourselves what 35 was. We had an f of x. It is equal to 1 over 1 plus x squared. We have a g of x, which is equal to 1/2 x squared. Once again, we're just graphing this. We have our quadratic first. I'm going to do that. That's the easy one. Goes along like this. This piece cruises up, cruises down, like so. I find I have an intersection here at -1, another intersection at 1, and once again, I'm going to use my even property for integration, which says that I can double the area from 0 to 1, and now work with the upper minus the lower. That's 1 over 1 plus x squared minus 1/2 x squared dx. This we can clearly see is our arctangent, so I have 2 times the arctangent. This is of x, and we're subtracting 1/6 x cubed, and we're going from 0 to 1. As we do this, we end up getting 2 times. I have pi over 4 is going to give me the arctangent of 1. Arctangent of 0 is 0. And then I have this piece, which is minus 1/6. Doubling this, I end up getting pi over 2 minus 1/3, and that's my answer. Notice it's a whole lot easier to use that the even property of integration. We're now going to take a look at number 37. 37 is now asking us to find the region bounded by the graphs over the interval. Same concept. We're looking at f of x equaling a cosine of x, and we have a g of x that is going to give us 2 minus cosine of x, and we're working from 0 to pi over 2, 2 pi. So graphing my cosine is simply going to give me, let's see, this function here. It's going to go up, curve down, curve up, and once again we're going to 2 pi, so we have point to point. Let's make sure we get there. So from 0 up to 2 pi, and then we have the cosine. Now this is upside down but shifted twice. Gives us a graph that looks like this. Mirrored image. So we're going from 0 to 2 pi. We have our upper minus our lower. So I have 0 to 2 pi of our upper 2 minus cosine x minus cosine x dx, which is going to simplify to 0 to 2 pi, 2 minus 2 cosine x, and I'm going to factor out the 2, giving me 2 integration 0 to 2 pi, and I have 1 minus cosine x dx. This can be integrated quite easily, so I'm just working with 2 times the integration gives me x minus sine x from 0 to 2 pi. And you'll notice that I end up having just 2 times 2 pi, and I'm subtracting 2 times 0, and it repeats itself. So my answer is 4 pi. All right, this brings us to number 39. As we're going through these quite quickly, number 39 is giving us f of x equals 2 sine x, and we have g of x is equal to the tangent of x, and we're going from negative pi over 3 to pi over 3. We're going to start by graphing. Now we know our sine does that, and we know our tangent falls between the asymptotes and does this. We're going to be going from the known value here to here to here. Pi over 3, 0, negative pi over 3. Now, I also can use my even integer that says that these two areas are the same. So I can go 2 from 0 to pi over 3, and I can work with my quadratic, or my sine, 2 sine x minus tangent x dx. Once again, trying to make life as easy as I can here. If we integrate this, we're looking at 2 of these 2 cosine x's, and it's got a negative in front. And I have the positive because of the negative natural log of the absolute value of cosine of x, and we're going from 0 to pi over 3. When we put this in, we have 2 times. This is going to give me a negative 1/2 when I put in that pi over 3. And I'm looking at, 1 minus the natural log of 2. And I'm looking at my answer right here. There's number 39. Please remember, this is our 1/2. That's giving me a negative 1, and I believe I have it from the minus. 0 gives me minus 2. So hopefully you can see that as we multiply through. Once again, this is a 1/2. Cosine of 0 is a 1. You're subtracting, and it does simplify. Last one, number 41. Number 41 is giving us f of x is equal to x e to the minus x squared, and we have y equals 0. We are working from 0 to 1. So if we graph this, here's my y equals 0, starting at 0 and moving toward 1. And I know that this graph is going to do something kind of similar to this. It goes up, and it starts to come back down again. So we can see that we have this on top, minus 0, the integration 0 to 1 for x e to the negative x squared dx. You're going to use a u substitution for this. You should end up getting negative 1/2 e to the minus x squared from 0 to 1, and you get negative 1/2, double negative 1/2, and then we have minus 1 over 2e. This is my answer. Now you can factor out the 1/2 if you wish, but I'm going to leave it just like that. And that was number 41. Alrighty, I hope that has helped. If you have any questions, please make sure you come in and ask. If you liked this video and you felt it was helpful, please remember to click like. Otherwise, give me suggestions on how I can improve. Thank you very much. Be safe, take care, and please be well, Hornets. Remember, it is easy to be mean, so please try to be nice to each other. Thank you. Talk to you soon. Bye-bye.